there we go. Thanks, Kiara. So yeah, welcome to the first virtual talk for Chemical Physical Society this year. And yeah, welcome. I'm glad you guys could come. I'm glad we could move things online. And yeah, so I'm going to first pass over to Tamara, who's our president this year, and she'll introduce Dr. Anna Roffey, who was our president last year.
You're muted, Tamara.
I was trying to get Anna's bio up, then realised I was muted. Yeah, so welcome everybody to CPS. I hope this year, I know it's virtual, it's a little bit different, but hopefully that might mean more people can interact or more people can join for the talks who previously wouldn't have been able to. So I hope it's helped in terms of that. We've still got some super interesting talks lined up, and we've been able to get people who probably wouldn't have been able to get to travel to London, so that's quite interesting. So our first speaker, Anna, I'm just sorry.
Don't you know already, Tamara?
I do, but I couldn't remember which university it was. Yeah, so this week's talk will be given by Dr. Anna Roffey. So after graduating from Bristol University with a master's degree, despite what you've seen in the previous communication, Anna then undertook a PhD at UCL. Nowadays, she's a teaching fellow in the chemistry department, and she was the president of CPS last year. So tonight she is sharing her talk titled "Are Pigeons Smarter Than Mathematicians?" It's the story of a counterintuitive maths problem solved by a female polymath in the face of overwhelming opposition. And I think that's your husband, right? Who's the...
Yes.
Yeah. Okay, so I'll hand over to you, Anna. Do I have to make you a host or...?
No, I'm already...
You're okay. Yeah. Cool. Brilliant. Thank you.
Thank you, Tamara. Okay, so I'm going to talk to you today. Oh, I'll switch my video on. Okay, I'm talking to you today about a couple of different things. And you've seen the title of my presentation, and basically I'm going to take you along a journey. I'm going to tell you a story, and hopefully by the end you're going to know a bit more about pedagogy and women in science. Okay, so before we get going on the actual talk, I want to just introduce you to, or get you going on the technology that I want to use in this talk. So hopefully you can see that slide. I would like for everybody to please, either on their phone or in their browser, open menti.com and enter this code. So you should be able to see that, 943793. And I'm going to give you 30 seconds to have answer the question that I've set there. It's just a practice fun question. I think it's fun. So 30 seconds to answer that question, and then I'm going to show the results on the screen and just make sure all of the technology is working. I can already see that some of you have made it there. The results are coming in, that's great. Okay, you got 10 seconds. 5 seconds. Better get your choices in quick. Okay, thank you everybody. I am now going to show the result. So hopefully you can see that screen where we can see that Star Wars is slightly ahead of Star Trek, which is, as a scientist, I expected Star Trek with that solid science background in the show to win. But Star Wars, I think we've got some Star Wars fans in the house. Okay, all right, let's go back to my presentation. I'm glad that that works. Okay, so who am I? Tamara has already told you a little bit about me. but I made this montage to just give you a little bit more information. So I started over here on the left as a child, and then shortly after that, I did a master's degree in chemistry at the University of Bristol, which was really fun. And I learned a lot, and I did my final year project with Professor Nick Norman. And he works with main group chemistry, and I was fortunate enough to synthesize some diborane compounds, and we managed to get some crystal structures, which was great, and I got a paper. Yay. So after Bristol, I decided to go and work for the Royal Society of Chemistry in their publishing division. So I became a publishing editor. And so I kind of saw the other side of science, which is the side where we get to decide who publishes their paper, which was an interesting learning experience. And if anyone ever wants to talk to me about what it's like to work at the RSC, I'm very open to talking about it. And also I know that Callie Haynes also worked there, so she also knows. After that, I wanted to get back into the lab. So I started a PhD at UCL. So I came to UCL many moons ago, and I worked with Graham Hogarth, who is no longer at UCL. And we were working on a project to do with what I was doing was inorganic synthetic chemistry. I was making iron sulfide precursor complexes, and then I was using them to make iron sulfide nanoparticles of different phases, different mineral structures. And so this image, on the right hand side, you see a high-res TEM. I took that TEM. I did that. So I made that and I took that TEM, and it was a really, really fun project. And we got some nice papers out of it. And we used my materials to as catalysts for CO2 reduction, which was fun. After that, I started a postdoc in Sweden at Chalmers University of Technology in Gothenburg, or Göteborg if you're Swedish. I loved Sweden. Sweden was a really, really fun place to be, and I tried some of the local delicacies while I was there. As you can see here, I am trying strömsö. It's fermented herring. So you can see how much I'm enjoying the fermented fish dish there. After that, I kind of realized that maybe research in science wasn't exactly what I wanted to do. I really enjoyed working with students and explaining things and teaching. So I came back to the UK and I started working at the Science Museum as an explainer. And that was a lot of fun. It's hard work working in the Science Museum, but a lot of fun. I met some great people. And then a position came up at King's College University, a teaching fellow position. And I thought, wow, perfect. I'm going to go and do that. And it was great. I worked in the chemistry department there, working with some really fantastic people. It was very hard work, but it gave me the background that I needed so that when a position as a teaching fellow came up at UCL about 3 years ago, I was able to go for that position and secure it, which was great. So that's the current job that I have, teaching fellow at UCL. So that's kind of like my professional life. In the meantime, in the middle, that's kind of what I do for fun. So that's me rock climbing. I don't even remember where that was. The last piece of protection is quite low. So I was being really confident that day. And I can't go any further without showing a picture of my cat Gruber, we've had him for 2 months, and I just have to always show a picture of him. Okay, so that's me. What do I do? So I'm interested in pedagogy. So pedagogy is such a strange word to use, and it doesn't mean a lot to a lot of people. So it's the study of teaching and learning. How do people learn? How can we best teach them? So right now I'm speaking to you in a sort of traditional lecture style. I am teaching you, I'm speaking at you, and you are receiving that information and learning from me, maybe. But there are other ways of teaching. There are other ways which are more appropriate at different times for different people and different topics. So kind of more active learning where the learner is more involved and students can lead their learning and things like that. That's the kind of stuff that I'm interested in. And that's what I do my research in now. And on the right-hand side, you can see a woman in STEM. So this is something else that I'm very passionate about. I am a woman in STEM myself, and I champion other women in STEM. And we recently got the Athena Swan Silver Award in the chemistry department at UCL, which is fantastic. And I was on, there were people here as well who were on the committee for that, to put that together. And it took a lot of hard work, but it shows that the UCL chemistry department are committed to promoting equality in the sciences and promoting equal opportunities for women. And that's really important, because I'm just going to quote some stats at you. In 2019, women made up 26% of STEM graduates. So STEM is science, technology, engineering, mathematics. So that includes physics, computer technology. And in the same year, women made up 24% of the STEM workforce. I think that's a really staggering statistic, that 76% of people working in STEM are men. And they're designing everything potentially with from a male perspective. And I think that is a shame that we don't have more of the other perspectives, other groups being represented. So anyway, those are the two things that I'm interested in at the moment and that I'm going to talk to you about today. So, okay, back to the topic of my presentation. Are pigeons smarter than mathematicians? So I'm going to take you through a story that connects pedagogy and women in STEM. I've got a little picture here of an archetypal pigeon on the left, and on the right you can see an archetypal mathematician. This is my husband, Dr. Robert Downs. He has a PhD from UCL in maths and theoretical physics. So maybe when you think of a mathematician, maybe you think of something that looks a bit like this, someone who looks a bit like this. Sorry. Okay, so the story starts with a fantastic woman in STEM called Marilyn Vosovant. So she's an American. She was born in America in 1946. She's regarded as a polymath, which means that she has expertise in lots of different areas. So science, mathematics, but also art, literature. She's a columnist, an author, a lecturer, and a playwright. She also holds the Guinness Book of World Record highest IQ. So she has an IQ level of 228 when it was measured. And that is about double a normal person, maybe a little bit more than double. So that's pretty impressive by anyone's standards, but even more impressive. So this is in the Guinness World Book of Records from 86 to 89. They actually stopped reporting IQ, the highest IQ in the Guinness World Book of Records in 1990, because they realized that actually it was a slightly flawed way of measuring intelligence. Not just slightly, it is a flawed way of measuring intelligence. But before that happened, she was the smartest person in the world, regarded according to this measure. So that's in the 80s. That's quite dramatic. That's perhaps a little bit unusual at the time. Okay, so that's Marilyn Vosovant. She had a column in the magazine Parade, where people would write in with questions, mathematical problems, logical problems, and she would answer them. And the story I'm going to tell you is about one of these questions that was posed to her about an American game show. And that game show was, let's make a deal. So some of you may or may not have heard of this game show before. It's been running since 1963. It was co-invented and presented for 30 years by this man here, Monty Hall. So there he is in his heyday, looking dashing. And the premise of this game show is a little bit like Deal or No Deal. Monty Hall would have a big audience, and he would walk into that audience and he would talk to one of the audience members, and he would make a deal with them. So he would offer them prize. It might be a known or unknown prize of medium value. And then he would try to persuade, convince, or otherwise get them to make a deal with him for an unknown prize that could be fantastic or it could be really bad. So the whole point of the game show was him kind of manipulating and making these deals. If the audience member made a bad deal, they would get a zonk. So classic examples of zonks from the program are, so these are like booby prizes that you wouldn't want to get. So a room full of broken furniture, or a live giraffe was another actual example from the program. If you were fortunate enough to win on Let's Make a Deal, you could win a Pontiac, which is an American car from the 70s that people quite liked. So that's the kind of premise of the game show that Marilyn was asked about. So this leads us to the Monty Hall problem. So it's a kind of classic maths problem. Here is the actual question that was posed to Marilyn Vosovant in her parade column. Suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car. Behind the others are goats, but you don't know where the car is. You pick a door, say door number 1. And the host, who knows what's behind all of the doors, shows you that door number 3 has a goat behind it. Then he says to you, do you want to pick door number 2? So the question is it to your advantage to switch your choice? Should you change from your original choice number 1 to door number 2? Okay, so now I'm posing that question to you. You have chosen door number 1. Monty Hall has just shown you there's a goat behind door number 3. What is the probability that the Pontiac is behind door number 2? Okay, so it's a Mentimeter question. So if you can go back onto Mentimeter, and I'm going to give you another 30 seconds to answer this question. So just need to, yes, so you should be able to see the question and answer the question now. Oh, it's over. Okay. So I'm going to show the result. Okay, so you should hopefully be able to see that. So we have 50% of you said it was a 50% chance. Well, that's a bit of a different. Half of you said there was a 50% chance that the car was behind door number 2. And just under half said there was a 1/3 chance. Oh, I've just realized something. Oh, I've just realized I've set this question up a bit incorrectly. Never mind. Okay. Just bear in mind that 50% of you said that there was a 50% chance of the car being behind door number 2. I did practice this quite a few times. Sorry about that. Okay, let's go back to the presentation. Okay, so this was Marilyn Vosovant's answer. She said, you should switch. The first door has a 1/3 chance of winning, but the second door has a 2/3 chance of winning. So I didn't actually give you the option to put 2/3 in, which presumably some of you who put 1/3 in might have put 2/3 in. I don't know. Sorry about So what do you think about that? Because I think a lot of you were thinking about this scenario on the right, where the chance of finding the car, once this goat was taken out of the equation, the chance of finding the car behind door number 1 or door number 2 is 50%, right? You've got a goat and a car, you've got 2 doors, 50-50. But that's not what Marilyn Mosfant said. She said 1/3, 2/3. Okay, so it's quite hard to visualize this 1/3, 2/3 answer. So I want you to go to Mentimeter again. And this time I'm going to ask you, do you believe Marilyn Mosfant's answer? Okay. So you've got 30 seconds to say if you believe or if you don't believe. Oh, a lot of you believe the answer. That kind of undermines my whole presentation. Okay, 10 seconds left to answer this Mentimeter question. And okay, let's look at how you answered. Okay, so a lot of you believe Marilyn Mosfant, which is great. And there are, there's still a significant number of you who don't believe her, and that's okay as well. I have to say that when I was first presented with this problem, and in fact, the second time I was presented with it and the 5th time I was presented with it, I still did not believe the answer. So you guys have done better than I have. Okay, so let's go back to what happened in the story. So you guys were pretty into her answer, but in real life, Marilyn Mosfant received over 10,000 letters about her response. The majority of those letters told her she was wrong in no uncertain terms, and many of those responses came from people who had PhDs in science subjects and maths. These are the kind of things that people said to her. You blew it. Let me explain. We love it when people explain. Please help by confessing your error and in the future being more careful. That's Robert Sachs, Professor of Mathematics at University in America. You are utterly incorrect. How many irate mathematicians are needed to get you to change your mind? Another professor of mathematics there. Maybe women look at maths problems different to men. Another sage statement there. And you are the goat, which is my personal favorite. So needless to say, she received a lot of backlash for her response to this maths problem. So even though quite a few of you do believe her answer, which I'm very pleased to see, and yeah, that's great. Not everybody does, and I certainly wouldn't at this point in the presentation. I found this quite difficult to wrap my head around. So if you haven't wrapped your head around it yet, don't worry. Okay, we're scientists. Almost everyone in here, I think, is a scientist, probably everyone. So what do? We'll run an experiment. Okay, so I'm going to just talk you through the experiment that we are going to run during this session. So I'll talk you through it. Then I'm going to ask my glamorous assistants, Kiara and Chris, to demonstrate it. So I'm going to run through it, then they will demonstrate it. Then I'm going to put everyone into breakout rooms, yay, to generate some data. So we're going to do the Monty Hall problem over and over again for 5 minutes. We're going to generate the data and see what proportion of times you win by switching your choice and what proportions of the time you win by sticking. So person A. So in each of the breakout rooms, nominate one person who has 3 cups. This is where the cups come in. So they don't need to be identical, the cups. They just need to not be see-through. So you need to be able to hide something inside one of the cups. You also need a piece of treasure. That can be anything. It could be a a piece of scrunched up paper, anything that fits inside the cup. So person A needs to hide that so that no one else can see which cup it's gone into. So person B, there needs to be a second person who will choose a cup. But once they've chosen, don't show them what's under that cup. It needs to remain unknown. Person A will then reveal one of the other cups, an empty one. So they know where the prize is, and they need to not show the prize, but show the empty cup that remains. Then person B, depending on the number of the breakout room that they're in, will either stick or switch. So if you're in an even numbered breakout room, every time you will stick with your original cup. If you are in an odd numbered breakout room, every time you're going to switch to the other cup. So if you started with A, you would now switch to C. Okay. Then there needs to be a third person, person C. So when it has been revealed whether the person B won or not, won or lost, person C needs to go to this live Google spreadsheet and enter that data point in. So each breakout room has its individual columns, one win, one lose. And so if you can use this QR code, or you can type in this tiny URL. I can copy and paste it into the chat as well. And we're going to generate our own data. Then we're going to look and see if it's true or not. Okay, so if I can now ask Kiara and Chris to...
Hello.
Hello, thank you.
Yes, you see.
Okay, so...
Okay, so I'm choosing your left cup.
Well, Kiara's
Yeah,
gonna...
yeah.
She hasn't hidden the prize.
Ah, okay.
So let me show you that they're all empty.
Okay.
There's nothing under there, don't worry.
It's like a magic trick.
I had one thing to do and I failed.
Don't worry. Now tell me where to put it.
No, so you're gonna hide it without him seeing.
All right.
We did practice.
We did. Don't worry. All right, the camera's off. You won't see where it goes. I'll move them around.
Great. Okay.
Okay,
So
so
now-
I'm choosing the left cup from your point of view.
This one.
Yes, this.
Fab. So I'll show you an empty one.
Yep.
This is an empty one.
So Chris, you are
And
in
breakout.
you're in an odd numbered breakout room.
So I should switch,
So
I
you
think,
should
yes.
switch. Yep.
So I'm switching to the middle cup.
Okay.
You ready?
Yep. You won.
Yay.
You won.
Okay, we're going to do that quite a few more times. We're just going to spend 5 minutes doing this. So I'll give you like a minute. I'll set up the breakout rooms, give you a minute to say hello, get some cups, and then 5 minutes to to do the experiment a couple of times, and then enter it onto the spreadsheet, and then we'll look at all of the data together. Oh, thank you, Stephen, for putting that. He's put it into the chat there. Okay, so I'm just gonna set up the breakout rooms. We've got 45 people, which is great. So I'm gonna do 9 breakout rooms. So there's quite a few of you in there, each breakout room, so you can have a good chat. So I've just put that slide up again so that if you need the URL, it's there again if you want. Okay, the breakout rooms are closing in 5 seconds. The last few people are going to join us. Okay, welcome back, everybody. I hope you enjoyed that. So I'm going to display the live results, which are not super promising. I'm not sure we really proved our point today, but I'm going to share them anyway. Okay, share. So you should be able to see that. Can you see the spreadsheet?
Yep.
Brilliant. Okay, so you input your data here, and these are our live results. So slightly concerningly, although we do see a sort of 2/3, 1/3 when you switch. So 2/3 of the time when you switch, you're winning, and 1/3 of the time when you switch, you're losing. The other side of the coin, which we expect, so when you stick, you should only win 1/3 of the time, and when you stick, you should lose 2/3 of the time. So that we don't really see that in the data, but probably it's not, the numbers aren't big enough to get out of the noise. So maybe if we did this 100 times, or maybe even 200 times, we would see that pattern come out. I did do this with a group previously, and I will now show you the results that they got, just to prove to you that it is possible to do this and get the right results. So I did this with the group. It was about as big as this for about as long, and these were the results. So you can see hopefully a different bar graph now. And when you stick, you lose 2/3 of the time, and when you switch, you win about approximately 2/3 of the time. Again, these numbers aren't exact. You need to kind of do this many times, just like rolling a dice to see that a 6 comes up 1/6 of the time. You need to roll that dice quite a few times to get that. Okay, so I'm going to go back to the presentation. Okay, so hopefully I have somewhat convinced you that that Marilyn vosovant was correct. Now I'm going to explain why. So a lot of you answered that you believed her answer before, and I wonder if you knew why. Maybe you did, because you all have a strong science background. So you have a lot, good maths literacy. But this for a lot of people is very difficult to grasp because it feels wrong. It feels like it should be 50-50 because you have 2 doors and you have 1 car and 1 goat. Shouldn't it just be 50-50 chance of getting the prize? But this is a counterintuitive problem. So it's something that we as humans find it a little bit difficult to get our heads around. So at the beginning of the game, before you select any of the doors, there is a 1 in 3 chance that the car will be behind any of those doors. So there's a 1 in 3 chance that the car will be behind door number 1. But the key to this is that you make a choice. You choose door number 1, and then you get a clue. So this is something called conditional probability. So something is manipulating the system. So I'm going to show you 3 scenarios. These are the 3 possibilities of the car being behind each of the doors. So the first possibility is that the car is behind door number 1. You've chosen door number 1. So if you stick with door number 1, it doesn't matter if Monty Hall shows you door number 3 or door number 2. If you stick with door number 1, you're going to win. The second scenario, you choose door number 1, but there's a goat behind door number 1. There's also a goat behind door number 2, and there's a car behind door number 3. Monty Hall will show you door number 2. So if you switch, you'll win in that scenario. In the third scenario, you pick door number 1, there's a goat. Behind door number 2 is the car, and behind door number 3 is the goat. So Monty Hall shows you that goat. And you will win if you switch in that scenario. So it doesn't matter if the car is behind door number 3 or door number 2, you will win in both those scenarios as long as you switch, because Monty Hall is always going to remove the goat option. So you will win if the car is behind door number 2 or 3. That's why it's a 2 in 3 chance of winning by switching. So this is the part that a lot of people find difficult to get their heads around, but that's the answer. I hope I've convinced you. Okay, Mentimeter, have I convinced you? There were 8 people who would admit that they didn't believe Marilyn vosovant, those brave people. I give you now 30 seconds to go back onto Mentimeter and just answer whether you agree now, or if deep down in your soul, if you believe that it's still 50-50. You can't agree with this mad maths. Ten seconds left. 5. Okay. I will show you the results. So you can see that I have convinced you. 31 of you agree with Marilyn Vosovant. I like to think it's because of my explanation and not because you already knew everything in this presentation at the start. Okay. So this was, although we've gone through it in the space of about 45 minutes, this was an incredibly big drama in the 90s. This caused a huge uproar. This made it to the front page of the New York Times, the controversy surrounding this answer, and the fact that Marilyn Vosovant received so much hate about her explanation from these amazing mathematicians. In the end, they had to, so they built these computer models to do exactly what we just did, to show what the probability really is. So if it came out 50-50 or if it came out 1/3, 2/3. So they corroborated her logic and she was vindicated because of that. To try and help people understand the answer better, Marilyn Vosovant designed an exercise which was then integrated into the curriculum in America. It was such a big deal, they integrated it into the curriculum to help people understand probability better. And then the fun part. After removing my foot from my mouth, I'm now eating humble pie. I vowed as penance to answer all the people who wrote to castigate me. It's been an intense professional embarrassment. So that's from Robert Sachs, who you might remember earlier said, "Let me explain." And just for anyone who kind of doubts that this was such a big deal, or anyone who feels a bit embarrassed that they still don't really believe that it's 1/3, 2/3. This is a picture of Paul Erdos. He is a huge figure in the area of mathematics. He was basically like a god to mathematicians. He was prize winning, he was prolific, publishing thousands of papers, including in the area of probability theory. He's regarded as one of the finest mathematicians that ever lived. And he remained unconvinced with her answer until he saw the result of the computer simulation. So this is a really tough problem, this sort of counterintuitive problem we struggle with, mathematicians struggle with. But what about pigeons? Pigeons. People have done various bits of research. So this comes back to the whole point of this presentation, which is, are pigeons smarter than mathematicians? And as you can see, I stole that from the title of this paper. So this group have, they did a research paper back in 2010, looking at whether animals also struggle with counterintuitive probability problems like this. And they set up a scenario where they had pigeons with 3 options, and the prize that they could win was grain. And so on day 1 of the experiment, the pigeons were switching roughly half of the time, something like 35-40% of the time. And after 30 days of doing this, they were switching 96% of the time. Then the researchers said, okay, well, maybe it's just a fluke, I don't know. So then they switched the probabilities around such that if the pigeons were to switch their choice after their original choice, they would actually lose 2/3 of the time. So they changed the probabilities around. And after 15 days, the pigeons were only switching 4% of the time. So they got it. They got it really quick. And today, even now on Deal or No Deal, people don't really get this. So I'll leave it to you to decide whether pigeons are smarter than mathematicians. So just to summarize, I've talked to you about a maths problem that when conveyed in a sort of traditional way can be a little bit difficult to understand, but often when we do something a bit more active, when we test a theory out ourselves, when we perform active learning, it's easier for us to understand. It's a different way to learn, and that kind of active learning can break down barriers to understanding. In fact, this one changed the curriculum in America, so that's kind of cool. And I've also hopefully given you a little insight into, she's actually quite a famous woman in STEM, although she was quite derided at the time. Women in STEM make a valuable contribution, as do many other groups that maybe aren't represented to the level that perhaps they should be. They're often hidden figures, and it behoves us to search them out and to talk about their stories and learn from them. So there are role models out there, we just need to look for them. Okay, so I would like to thank a couple of people. Firstly, I don't think he's here, but I'd like to thank Rob Palgrave, who actually designed this whole activity that we've just done with me at the Yale Summer Institute, which is it's like a summer camp for learning about active learning and teaching techniques run by Yale University. I'd also like to thank Rob Downs, my husband, who has provided this wonderful photograph, and also for the original idea, him being a mathematician. And fruitful conversations, all the times where I said, no, it has to be 50-50. It can't be true. So thank you, Rob, for putting up with that. And finally, I would like to thank, from the bottom of my heart, thank the CPS. So this is a photo of the CPS committee from last year. They work incredibly hard behind the scenes to make CPS happen, and we had a bit of a rough year last year with the strikes and then a global pandemic, and they were fantastic during all of that, and they are working incredibly hard again now to bring you these events, and yeah, their creativity and their enthusiasm and all in their own spare time is amazing, and I'd like to thank them and thank you for listening.
Oh, it's a bit strange when you can't hear applause. Thank you, Anna. That was such an interesting talk. I was a no at the beginning, but only because I'm really bad at maths, not because I doubted her.
No, you can say no. I doubted it for like 6 months. It took for me to get my head around.
And then when we were doing some of the experiments, we were like, oh, in my breakout group, we were kind of doubting it. But as with most science, you just can do it and do it until you get the result you want. So yeah, thanks everybody for listening. I think the CPS guys have got something planned. I'll pass them on to you. Normally, oh, actually, sorry. I'm totally missing out questions. Does anyone have any questions for Anna? I don't know, I think it would probably be best if you unmute yourself, maybe, if I allow you, or if you raise your hand and I can unmute you. Or if you want to type in the chat, if you don't want to speak out loud. I think I saw a hand. Yeah, Susan.
Hi, thanks ever so much for such an interesting lecture. I perhaps grew up with little problems like this, but don't you think it could be different ways of calculating? And I hope you don't mind me asking that. Thank you very much indeed.
Yeah, so I have to confess I am not a mathematician. So to get down into the deep into conditional probability, I would have to call my husband down from the spare room so that he could explain the maths behind all of it. But hopefully the explanation that I gave kind of gives an insight into why it's 2/3 and 1/3. I think a lot of people look at this problem and they kind of take it separate. So they look at the probabilities being 1/3, 1/3, 1/3, and then in the second half where you see one door has been taken out of the equation, they look at that as a fresh new problem where there's just one goat, one car and two doors, therefore it must be 50-50. I think that's the main issue with understanding this kind of counterintuitive problem. So you have to just remember that actually you can't take it in isolation. It's a conditional probability problem.
Anna, I have a little question. I'm just sort of thinking of Noel Edmonds' strange makeup face. So would it be the same thing for Deal or No Deal?
Should be the same.
So you should switch.
You
Oh,
should
wow.
switch.
Yeah.
Yeah.
Cool. Any other questions for Anna? Maybe not about.
Oh, I have a question. Sorry, I don't know how to raise my hand on Zoom.
Oh, no worries. If you just unmute yourself, that's fine.
Okay. Anna, that was a fantastic talk. We really loved it. But my question is not so much about the pigeon or the probability, but that was a great display of how probably everyone would like us to be doing our teaching. It was really interactive. You used a Mentimeter and you used, compiled a spreadsheet from people submitting results. I mean, I think that ticked just about every box. So lovely showcase there. I'm just wondering, how long does this sort of thing take to put together if you're starting from just, I don't know, asking for a friend, a lecturer's point of view, and you'd like to be able to do a lecture that had that level of interaction? How much commitment does that take from you? How long does that take?
Well, originally when Rob Palgrave and I made the first exercise, it took us collectively together a few hours, I have to say, a few hours, but that was also thinking of a really fun, active learning activity to do.
Yeah, that's the thing. If there was a list of these, because it was so fun, I loved it, and I'm impressed with you having the extra spreadsheet that you'd done before, just in case. That's probably where it all fall down in my lectures.
Yeah, it's like Blue Peter. Here's one I made earlier.
It was perfect. Yeah. No, well, thank you very much. Anyway.
Welcome.
Anyone else want to unmute and ask any questions? Okay, if not, just, really thank you, Anna, and just the same as Caroline, probably everyone will
Thank
be.
you. It's great fun.
So I'll just pass you on to Chiara.
From the whole committee, we want to say thank you so much for being the president for the whole of last year. Despite all the strikes and everything, we're so glad you got to do your presidential talk now, even if it's in a new way. I think it even helped.